Hey, hello there. So today I'm looking at the question 1288, remove covered intervals. We have a list of intervals. We want to remove all the intervals that are covered by another interval in the list. We can say that interval AB is covered by interval CD if and only if that interval AB lies within interval CD. So after we do all those removals, we want to count the number of remaining intervals and return the count. The example question example is 1, 4, 3, 6, and 2, 8. We can see that the middle interval 3, 6 lies within this bigger, longer interval 2, 8. So we have to remove 3, 6. And we find that 1, 4 and 2, 8, even though they intersect with each other, but it's not the covered relationship. They are just the left-hand side from 1, 4 that's outside 2, 8, and the right-hand side of 2, 8 from 4 and on is outside 1, 4. So those two are not covered by each other. So we return 2 for 1, 4 and 2, 8. So that's the example and the question. One brute force solution is basically compare all the pairs of intervals and do this covered test. The covered test is cheap. It's pretty much just two comparisons, so it's constant. The not so ideal thing is the pairwise, if we actually compare all the pairs. So if we have n different intervals, the runtime will be n squared. And also there is a little special case that we want to handle inside this potentially double for loop brute force solution is that what if we have duplicates? We have two intervals that can cover each other. We need to make a choice about which one to keep, but it's not a too difficult thing. So the moral is the pairwise comparison is n squared. It's not ideal. The big reason is that there are just two intervals that we don't have to think about whether they cover it with each other at all. And if we do pairwise comparison, we do a lot of those unnecessary work. So we want to look at this comparison in a sort of like order and only do the comparison, the covered check as necessary. So we're gonna look at the intervals in a order. What kind of order would that be? I think it might be easier to think about this when we actually visualize the problem. So this is the problem space. We have a number line here indicating the the starting point, end point for the intervals, and we just copied over the question's 3 different intervals: 1, 4, 3, 6, and 2, 8. So the way we're gonna do this question, look at the problem space, explore this problem space, is to have a vertical line that's sweeping through this problem space. The first time we find an interval, we just remember we see this interval 1, 4. Because this is the only one we see. We don't want to do any comparison, any test whatsoever. All we need to do is basically just remember we have seen 1, 4. Then we keep going and see another interval. Can I move faster? Yeah. So the second interval we see is 2, 8. At this time, it's guaranteed that we have the prior interval, so starting point, to be smaller than the starting point for the next interval we encountered. So in this example, it will be 1. The left point for the first interval, that's 1. It's guaranteed to be less than or equal to the left point for the second interval, subsequent interval we see. So we have the we have the C less than or equal to A already taken care of if we do this sequential kind of a line sweeping order of looking at intervals. The only thing that we need to do right now to determine whether this 2, 8 is covered by 1, 4 or some other prior interval is to see the right hand side. Excuse me. So 2a ends up on the right hand side, it ends at 8, but the prior intervals, so all those intervals that satisfy the condition C is less than or equal to A, the right hand side, the only right hand side we now have is 4. So since 4 is less than 8, we can conclude that 2, 8 is not covered by any prior intervals we have seen. So the next step is to move this line towards right even further. The new interval we encountered is 3, 6. So this point we are pretty sure all the prior intervals 1, 4 and 2, 8, they all satisfy the C is less than or equal to A condition. All we need to do is to test this B is less than or equal to D. So the B here is basically the right hand side for this current interval we are looking at. That's 6. And we know we have seen 1, 4 and 2, 8. The largest D we have is 8. Since that the 6 is less than the largest D prior to seeing this interval, we can conclude that 3, 6 is covered by one of the prior intervals. Which one? We actually don't really care. So we have to remove 3, 6. So in this way, you can see that when we sweep the line from left to right, we are looking at intervals in the sorted order of their starting position. So we want to do an n log n sort, and after that we can do a linear sweep to test for this covered condition. Okay, there's just one more thing to talk before we go to the code. That is, for those intervals that has a tie in the left hand side, so for the intervals that have the equal, they have the tie to the left hand side, the line is gonna sweep through them at the same time. We have to decide the order we look at all those intervals. I guess it's easy to see that we want to look at them in the from the we want to examine all those intervals in the order that sorry, I try to make the graph look nicer while trying to talk, which is very hard, bizarrely. We want to look at all those intervals in this order. We want to look at the longest one first and look at the shortest one, because the longest one can potentially cover the shortest one. But if we look at the shortest one first and the longest one, we might conclude, using the logic as described above, we might conclude that the second one is not covered by the first one. So for that reason, we want to sort based on the starting point, and if we have a tie, we sort on the reversed order of the the right hand side. After we do this sort, we just do a linear line sweep to test the covered or not. At any given time, we can summarize all the intervals we have already examined by a single number. That's the longest right hand side. So that's the question, and also the sort of like illustration about how we use the line sweep to leads us to sorting and linear scan. So that's that. Let's code this thing up. So we're gonna sort these intervals by the left hand side first in the increasing order, so, and then in the reversed order of the right hand side. So if we have a tie on the left hand side, we want to examine the longer one first, and we create a count that's 0 in the beginning and do this sweep line operation. So we're gonna remember the maximum right hand side we see initially is just 0. And we're going to look at the starting point and end point for the interval in the sorted order. So the test about covered now is only this part, B is less than or equal to D, because we're looking at this in the sorted order. It's guaranteed that we will always have the previous left to be less than or equal to the current left we're looking at. So all the tests we need to do is test the right hand side with the previous maximum. So if the previous maximum is larger than or equal to the current one, then the current interval has to be covered by some prior interval. We just increment the count. Otherwise, we will just to do this update. Yeah, so that's pretty much the code, I think. Let me try to run this through. No, it's not out. Oh, okay. So this is the I'm counting here. I'm actually counting the number of intervals I'm removed, but the question asked me to return the number of remaining intervals. So I will just return the difference then. All right, so that's the question. It's not too difficult to think about this, and honestly, if it's not that I'm trying to look up for the sweep line question, I might not even to actually thinking about this with a physical line crossing this. But definitely, if we visualize this and actually have this line sweeping operation, we can very easily see why we want to sort the intervals by the left hand side in the increasing order, and if we have time, we sort by the right hand side in the decreasing order. It's kind of it's very clear if we do have a line here that guide us to think about this, but I don't think it's too necessary for this particular question to really think about line sweeping. Anyway, the runtime for this is n log n plus n. The n log n is the sorting. The line sweep here is a linear path. So that's this question today.